Today's lesson is on theoretical probability. So yesterday we did a review, or on Friday. Today we'll be going a little bit deeper into theoretical probability. This lesson only covers one page. It's just page 185. Question 1 asks you to circle the numbers that mean 1/4 in terms of probability. So there are a wide variety of options that they give you. I've changed the number. Your question will say 3/4, and I've changed a lot of these here just so we can kind of look at whether they are the same probability. So we could start with our first option is a percentage. So is 14% the same thing as 1/4? Well, the easiest thing to do might be to calculate 1/4 as a percentage. So to figure out what percent it is, we want it to equal something out of 100. So we need to multiply it by 25, and that will give us 25 out of 100, which is 25%. So no, 14% is not the same, but we could now look at all the other percentages. The only other one is here, 25%, and that is the same percentage. Then we could look at our next one is a fraction. 4 out of 1. Is 4 out of 1 the same thing as 1/4? No, right? Because you can't, this is the reciprocal, but they do not give you the same amount. Is 0.1 the same? Well, we could figure out what it would be as a decimal. So to go from a percent to a decimal, we just divide it by 100, right? So it would be 0.25. So this is not equivalent. Is 10 out of 40 equivalent? Well, let's see. Is there anything that we can divide it by to get it to be 1/4? Well, if we divide it by 10, 10 divided by 10 is 1, 40 divided by 10 is 4. That one is equivalent. What about 1 plus 4? 1 plus 4 out of 4 plus 4 is 5 out of 8. I can't simplify that anymore to get it back to 1/4, so that does not work. 1 out of 4 in words is the same thing as saying 1/4, right? 1 piece out of 4. It's like we're writing the fraction as words, so that one is equivalent. 1 times 2 over 4 times 2, that gives us 2 out of 8. And if we divide the top and bottom by 2, we get back to 1/4. So that simplifies, so that one is the same. 3 out of 12. Well, we could write 3 out of 12 as a fraction, right? And then we could divide them both by 3, and that would give us 1/4. So that one is equivalent. 25 out of 100. We've already figured out that that is the fraction that takes us to the correct percentage. 3 out of 4. Well, there's no way we can go from 3/4. We can't get to 1/4 from that. So this one does not work. So it's just kind of a way to go through all of those different ways of writing probability to see which ones are equivalent. Question 2 is going to ask you to express each probability as a fraction, a decimal, and a percentage. So remember, with the fractions, we are always simplifying it to lowest terms. Okay? So that's why if we look at this first question, where we have the probability of R, or probability of red, there are 2 reds out of 4 options. So that's why they simplified it to 1/2. Then they wrote it as a decimal equals 0.5, and then as a percentage, 50%. So for probability of B, we'd have to write the total number of B's is 1 out of, how many are there? 4. Can we simplify that? No. So there is our first fraction. Then we need to turn this into a decimal. So we need to make the bottom into a power of 10, right? Into a decimal fraction. So we can't turn 4 into 10, right? We can't multiply to get there. So then we'd have to look at 100. Can we multiply 4 to get to 100? Yes, we can. So to get to 100, we would multiply it by 25. And 25 out of 100, as a decimal, there's 2 zeros in the denominator, so we'll have 2 zeros after the decimal, and then we fill them up starting at the end, and it matches up. So this would be 0.25, and this is also the same as 25%. The probability of spinning any color, which is this third question here, how many square spaces could give you any color? All of them. 1, 2, 3, 4. So it will be 4 out of 4. And what could we simplify this to? Well, this could become 1 out of 1, right? So we will guaranteed get it every time. What is this as a decimal? Well, it would just be 1.0, or we could write it as 1. And as a percentage, this is 100 out of 100, so that is 100%. There's a 100% probability that you will spin any color, unless your spinner breaks off and runs away. So for each question, think about how many, so remember your numerator is how many have what you're looking for, so how many have R's. Your denominator is how many spaces are there all together, or in the case of the marbles, how many of marbles are there all together, okay? Fractions in lowest terms, turn it into a decimal, and then write it as a percentage. Question 3 asks you to circle the numbers that can express probability. So there are different formats that you can use to express probability. Probability can be expressed as a percent. It can be expressed as a fraction. But here's the thing with the percents and the fractions. Can the percent be more than 100%? No, right? Has to be less than 100%. Can the fractions be more than 1, right? They have to be equivalent to 1 or less. So if we're looking here, 1/3 could express probability because there's one way out of 3 chances, that's fine. But you can't have 3 R's but only 1 space, if that makes sense, right? So just to kind of clarify those. You could also express it as a decimal. You could express it as but once again, has to be 1 or less. It has to be, less than 1 for all of these. You could also express it as a ratio. So a ratio is like 1 to 2, but your first number will always need to be smaller or equal to your second number, okay? When it comes to whole numbers, the only whole number you could use is 1. When it comes to integers, you could select integers that are positive and 1 or less. So basically, any integers that are a positive decimal, that is 1 or less, are fine, but you could not have a negative integer for probability. Question 4 asks you to describe an event that has the following probabilities. So an event could be a real life event, but it could also just be a scenario with like flipping a coin would be considered an event. Spinning a spinner would be considered an event. pulling a marble out of a box or a bag would be considered an event. So what is one that has a 100% probability of happening? It will happen. Now, you could look back at question 2a. The probability of any color was 100%. So for that, you might say, right, the probability. Question 5 is going to ask you to check the probability of rain and convert it from a percent into a fraction in the lowest terms. So I'm just going to do A with you. If A, there is a 60% chance of rain, 60% is 60 out of 100. Now our job is to simplify. So is there anything we can divide both 60 and 100 by? Well, they both have zeros at the end, so we could divide them both by 10. That will give us 6 out of 10, and then those are both even, so we could divide them by 2 to get 3 out of 5. Now, it's absolutely fine if you are starting smaller. You could start by dividing it by 2 and divide it by 2 a whole bunch of times. I personally would probably divide it by 20 right from the get-go and then make my way to 3 out of 5 because I know that that's the greatest common factor. So either way, 3 out of 5 would be the probability that's equivalent to a 60% chance in lowest terms. So you'll do the same thing, 35%, 75%. In baseball, a batting average is the ratio of the number of hits to the number of times a player has a turn at bat. So batting averages are decimals that can be changed into fractions out of 1,000, okay? They usually measure it out of 1,000. So a batting average that's 0.427 is 427 out of 1,000. So it means that the player had 427 hits in 1,000 times at bat. So your job will be to find the probability of a hit given by a player's batting average and then to reduce your answer to lowest terms. So our first step is to turn the decimal into a fraction. So if we look at question A, 0.125, that's going to be 125 out of 1,000. And if you need help remembering that, there's 3 places after the decimal, right? It goes to the thousandths place. So that's what our bottom number is. It has 3 zeros. Then we need to simplify. So you might have different ways of doing this. You might start by seeing that this is divisible by 5. You might start by seeing that this is divisible by 25. That's what I'm going to start with. So 25 into 125, 25, 50, 75, 100, 125. So there's 5 groups. And then if I'm looking at 1,000, well, 25 goes into 100 4 times. So it should go into 1,040 times because that's 10 groups of 100. Then from here, I could divide it by 5 one more time, which means I could probably have divided it by 125 from the beginning. 5 divided by 5 is 1. 40 divided by 5 is 8. So there is a 1 in 8 chance of them hitting the ball when they are at bat. Okay, so you're just looking for this fraction in lowest terms. Then you would do the same thing with B. Question 7 asks you which player is most likely to have a hit, and they give you their averages or their probability in 3 different ways. So I'll do A with you, and then I'll let you do part B on your own. So we need to make these all have a common format. So we've got 0.425, which if we write this as we could write all of these as decimals or all of these as fractions. So I might write them all as decimals. So 0.425, 4 out of 10 pitches is going to start as 4 out of 10, which equals, there's 1 0 in the denominator, right, in our decimal fraction. So there's 1 space, and that goes with the 4. So player B is 0.4. Player C hits 42%, and 42% is 42 out of 100, which is 0.42. So before I can compare them, I have to make sure that they kind of go to the same place. So I'm going to use a different color here, but my furthest place is the thousandths, right, for question A. So I'm going to make each of these add zeros until they all make it to the thousandths place. So my lowest number is 400, then 420, then 425. So player A is the most likely to hit it. For question B, when it says 1/4, just think of how you'd write that as a fraction, okay? 1/4 is the same as 1 out of 4, and that should help you with solving question B. And that is the end of this lesson. There will be a Google form for you to answer a few questions just to see how it's going, and feel free to ask me for a Zoom meeting if you need any help.